this here by x plus 1. This is saying that x plus 1 is a factor of f of x. Well, if we want to factor this completely, why don't we divide and see what's left over? And that's what I'm doing here. So I put the negative 1 here, right? It has to be x minus something when you're using synthetic division. The coefficients I put here, we have 1, 5, minus 1, minus 5. The 1 comes down. We get to use synthetic division. We get to use that. So remember, what's the process? We multiply. The answer goes in here, which is what I have over here. What's the next step? We add. So what should go down here is 4. And right. This was on the previous slide. You add and you get 4. What do we do next? We repeat the process. We do negative 1 times 4 to get negative 4. Then we add to get negative 5, as you can see. Again, I'm showing all the calculations here, so that's why I have so many of these tables. Next, negative 1 times negative 5 is 5, right? So here we should get a 5. And then if we add, we get 0. 0 should be here, and that happens here. Again, on the exam, if there's a question where you have to do synthetic division, if you show me this, that's fine. You don't have to show me every single step like I'm doing with all these tables. I'm just showing all of these so everyone understands. But this would be what I'm looking for. You know, if I asked you to divide using synthetic division. Okay, so we have this. Now, what does this tell us? Well, for one thing, it tells us, which we expected, the remainder is 0, right? We know that x minus negative 1 is a factor, hence the remainder should be 0, which is what happens. What we're looking for is the quotient, and these give us the quotient. This is degree 3. The quotient is degree 2. It's 1 less. So we get x squared plus 4x minus 5. X squared plus 4x minus 5. And that's what we get. So how does this help us with factoring? Well, this is what we end up with, right? So we were able to factor out x plus 1 using division. I mean, again, the factor by grouping is another option I think most people did, so that's okay. I mean, that's why I kind of threw out the question, because I probably should have used a better polynomial that you could not use any of the factoring techniques we saw earlier. Now, looking at the quotient, this one's a lot easier to factor. I mean, you could, if you wanted to, apply synthetic division, but you would have to figure out, though, what numbers are roots of the quadratic here. Although you could do that because we have the quadratic formula. But here I'm just using the, what do you call it, that one of our techniques from earlier, right? Since we have a trinomial with a leading coefficient 1, degree 2, we want two numbers whose product is negative 5 and the sum is 4. That's what I'm saying here. Okay. So what numbers pull that off? Well, you could probably tell even though it's here, but if this wasn't here, you should be able to see that 5 and -1 work. I mean, I didn't mention this in the course, but the sign of the coefficient of x is the sign of the biggest term. So we have 5 and -1, right? So since this is positive, the bigger of the two terms here should be positive. So since this is positive, the bigger of the two terms here should be positive. Hope that makes sense. I mean, if it doesn't, that's okay, but that's all right. From here, we get this can be written as x minus 1 times x plus 5. So this is x minus 1 times x plus 5. Right? This is a plus, the sign of the coefficient of x. And 5 is the bigger of the roots, it gets a plus when factoring. Altogether, we end up with this factorization. Okay, good, good. Okay, so that's this example. Are there any questions about this?